Today I'll be demonstrating how to draw bromine pentafluoride with the molecular formula of BrF5. So as we know, based on a periodic table, fluorine has 7 valence electrons. But there are 5 molecules of fluorine, so that's going to equate to 35 valence electrons total. And we also know that bromine, based on the periodic table, has 7 valence electrons as well. So this equates to 42 total valence electrons that need to surround, or that need to be in the atom. So we'll begin by putting bromine as the central atom based on the fact that it's the less electronegative element, as fluorine is the most electronegative element. So we'll start by putting the fluorines around the bromine. We'll begin adding electrons to the fluorine to complete the octets of the fluorine. And we'll have, by the end of this, after adding 6 electrons around the fluorine apiece, we'll have 30 electrons around the fluorine, and we'll have the 5 structural pairs between the bromine and the fluorine, which equate to 40 valence electrons. However, we need 2 more, and any molecule after the period 3 on that periodic table can have 2 extra valence electrons around the central atom. So this equates to 42 total valence electrons, which complete our bromine pentafluoride. And however, for its structural geometry, we have bromine pentafluoride here. And because it has 1 lone pair, but it has these 5 structural electron pairs around it, we can then demonstrate that this will not have ideal bond angles, but it should be octahedral electron geometry. So in an ideal world, you'd have a 90-degree octahedral geometry. However, because of this lone pair, we only have bond angles of 84.8 degrees, which is not the ideal bond angle. And our molecular geometry for this should be square pyramidal due to having 5 electron pairs with sigma bonds and then only 1 lone pair, which should equate to, square pyramidal structure. And now this is going to be a polar molecule due to the fact that this is a lone pair right here. And so it repels these fluorine, and it's not correctly, positioned. So it's not the ideal bond angles that you would expect to find of 90 degrees.